Today, we will be discussing objective number 3, electrolysis of lead bromide, electrolysis of lead 2 bromide, electrolysis of concentrated hydrochloric acid, and electrolysis of aqueous sodium chloride if time permits. So without any further delay, let's go straight to the electrolysis of molten lead bromide. The formula for lead bromide is Pb Br2. Now, can someone tell me why the 2 is written where it is? Why is that 2 there?
Because the lead and bromine switch the amount.
Amount, what is that amount called? What do we call that amount? That is
Valence.
The valence.
the valence, yes. Because lead, Pb, has a valence, it says it here in the name of the compound, lead 2 bromide. So lead has a valence of
Bromine.
+2, and bromine has a valence of -. So you swapped the valence. Okay, so the 2 from lead goes to bromine. You swap the valence, but not the charge. Okay, and the 1 there, the imaginary 1 from bromine goes to lead. Okay, so the compound is written as Pb2. Now, this is a molten compound, and what that means is that you heat lead bromide until it melts and separate into its 2 ions. The 2 ions are now free to move once this compound is molten. Okay, so this is what happens when you heat lead bromide, Pb Br2, you literally break the compound apart so that you've got Pb2 plus ions and lead ions, Pb2 plus ions and lead and bromine ions, Br minus ions. So those are the ions you can see there in my electrolyte. Okay, as you know, an electrolyte can only be a molten or aqueous solution of your ionic compound. So in this case, our electrolyte is molten lead bromide. Because bromine there is a negatively charged ion, the bromide ion there is negatively charged, it will be attracted to your anode, the positive electrode, because opposite charges attract. Yes, everyone with me so far?
Yes.
Okay, so opposite charges attract. So the bromide ion will move to the surface of your anode, and there it will give up its electron, the 1 extra electron that it has that gives it the negative charge. This negative charge is here because bromine atom has got 1 extra electron, making it a bromide ion. Now, when this bromide ion moves to the surface of your anode, it will give up that 1 electron to become a bromine atom. Okay, each bromide ion will do the same. All the bromide ions in this molten compound, this electrolyte, will move to the surface of the anode and give up their electron to become a bromine atom. This is the reaction that takes place at the anode. We refer to this type of reaction a half equation. So we say it's a half HALF, half equation, okay, at the anode. So the half equation there, it's Br minus 1 electron, okay? That minus sign there, it's saying that it's indicating that your bromide ion is losing 1 electron. So minus 1 electron forms Br atom. Note that the bromine atom has got no charge. Because atoms has got no charge, the number of protons and electrons are balanced. Therefore, they've got no overall charge. Every bromide ion will do the same. So let's look at another bromide ion will do exactly the same. Br minus 1 electron goes to form Br atom. Now, bromine as an element is not stable in its atomic state. Bromine is not stable in its atomic state. It's an element from group 7 or 17 of the periodic table. Okay, and these elements, they're only stable as diatomic molecules like fluorine, chlorine, bromine, iodine. They're stable only as diatomic molecules. So chlorine
Why are they not stable?
naturally as F2. Okay, this is when they're at their most stable. Okay, so any substance that is stable in a particular form will always strive to reach that form. Okay, so bromine is no exception here. These bromine atoms are not stable as atoms, so they will react with each other to form bromine molecule, and this is where they are at their most stable. Now, this example here that I've written is just an explanatory example. It's just to explain to you what actually happened, how the bromine molecule is actually formed. But if I was to write the half equation that takes place at the anode, I will combine both of these reactions, and therefore my half equation will look like this. 1, 2, so I'll have 2 bromide ions, okay? That is referring to this one and that one. So 1 plus 1 there give me 2 bromide ions, minus 2 electrons, 1, 2. So I add those electrons as well. So minus 2 electrons goes to form Br2. So this is the half equation for the reaction at your anode. This half equation could be written in another way, and you will see in most texts, you will see it written the other way around. Okay, this is because I prefer to write it like this, because students tend to grasp better having the minus sign there indicating that the 2 electrons are being lost. Okay, but the other way that you'll see this written, perhaps in your textbook, page 73 actually, of your textbook, okay, you'll see it written like this: 2 Br minus arrow, and your products of this electrolysis process, this decomposition process, is Br2 plus 2 electrons. Now, either way is correct. Whichever way you choose to write your half equation, it is correct. Okay, it is just another way around doing it. I personally think this is the easier way to do it. You may think differently. You may understand this as reactant there and product there. Of course, the electron's loss is part of the product, and the bromine molecules produced is also part of the product. Okay, so this is what happens after the electrolysis at your anode. So it's part of your product. Before that, you've got bromide ions. So it's up to you to decide which way you want to write your half equation at your anode. Now, the electrons that were given up, these two electrons that were given up at the anode travels through the circuit from your anode to your cathode. So now these electrons are in the cathode. Your lead ion there, Pb2 plus ion, will move to the surface of the cathode and accept two electrons to form a lead atom. Of course, if a lead ion has got a 2 plus charge, it means that it has got two protons more than it has got electrons. Okay, it has an electron deficit, okay, by 2. So when it gained 2 electrons, now its protons and electrons will be equal. And this is giving it an overall 0 charge. And that's what an atom is. Okay, an atom has got no charge. So the half equation at your cathode will look like this. Pb 2 plus 2 electrons goes to form Pb. That is the lead atom. Now what you can see here, these beads of lead that are attached to your cathode, these are thousands, perhaps millions of lead atoms building up there to make this bead of lead coated onto your cathode. Eventually, these beads of lead that are coated onto your cathode will get so heavy as layers and layers are coated onto the existing layers, they will fall off and form a heap of lead. They will fall off and form a heap of lead below there. So there you'll have lead, pure lead forming below there. Okay, that is the lead that would have fell off from your cathode. Now, as you can see here, let's go back to the anode. At the anode, the bromide ion gave up its electrons. So its electrons are lost. Bromine lost its electron. Now, whenever electrons are lost, then the process is oxidation. Yes, we haven't spoke in detail about oxidation and reduction as yet. But just remember this, for the purpose of this chapter, we will talk about oxidation and reduction proper later on. But whenever electrons are lost, oxidation is the process that is taking place. And here, that electron that bromine lost was accepted by lead ion. So lead gained electrons. Electrons were gained at the cathode. And therefore, the process there is reduction. We said that lead has been reduced. So note, okay, I'll come to you boys in a minute. Oxidation always takes place at your anode. Okay, oxidation always takes place at your anode, and reduction always take place at your cathode. Okay, let's get Muhsin, sorry, not Muhsin, Muhammad Muhammad Usman, what's your
Uh,
question?
Teacher, I have two questions. The reduction and oxidation process, do they have any practical uses? Like, do they do electrolysis
Oh, yes, yes.
for
Oh,
reduction and
my
oxidation?
goodness. Oxidation reduction,
Yeah.
probably the one of the most, if not the most important um, chemistry practices in industry, in big industries. You're talking about extraction of metals, iron in the blast furnace.
So
Iron
then
is produced from its oxide by carbon. Okay, copper is reduced from its oxide by carbon as well. Okay, aluminium, no, not aluminium, but most of the middle reactive metals, when you look at the reactivity series of metals, those middle reactive metals like iron and zinc, okay, and lead, they are produced by reduction using carbon. So yes, oxidation and reduction is very important, and it's used extensively in industry. What's your
and
other
this is
question?
mainly produced by electrolysis, right? Or are there other ways to get oxidation reduction?
No, no, not electrolysis. And reduction by carbon is based on the fact that carbon is more reactive than those middle reactive metals in the reactivity series. So a more reactive metal will displace. It's a displacement reaction. It's based on displacement reaction, which we are expected to do in grade 9 this year. We never had to do it previously, but this year we are expected to cover extraction of metals in grade 9. So hopefully we get there, and then you'll see what I'm talking about. Yes, it's a type of reaction called a displacement reaction, where a more reactive substance, a more reactive element, in this case carbon, will displace a less reactive element from its oxides. So oxidation is also, sorry, reduction is also known as the loss of oxygen. So the metal oxide, for example, iron oxide will be reduced by losing its oxygen, thus producing pure iron. Yes,
And when the lead atoms fall, do they produce? Did they just produce lots of lead, or do they produce something else?
no, just lead. Just lead is produced. Pure lead. Pure lead is produced. 100% lead. Malik Fakhouri, your question?
Teacher, there's something I don't get about the reduction part of the lead. I don't
Okay.
get where it gets its electrons from. I mean, yeah, yeah. Where does it get the electrons from? Do
Okay.
they just pop up out of nowhere?
Do you remember the electrons that were given up by the bromide ion at the anode?
Yeah.
Those electrons travel through the circuit from the anode to the cathode.
Oh, the circuit.
Yes, this
Okay,
wire.
I overlooked that.
Yeah. So that's how that's where it gets the electron. And then the lead ion moves to the surface and accept those two electrons.
Okay.
Yep. Any other questions, guys, before we move to your assessment for learning exercise? Any other question? Grade 9C, any other question? Okay.
Wait. So the negative charge that the lead or lead, I don't know, takes it. They take it from the bromine atom.
Yeah, the bromide ion relinquished its electrons. It gave up its electron, or it lost its electron when it moved to the anode. And those electrons traveled through the circuit from the anode to the cathode.
Okay.
And there, those electrons are accepted by the lead ion to form lead atoms. Okay, let's move on to our next slide. Now, practice question. Which statement about the electrolysis of molten lead bromide is correct? Which statement? Take a minute, go through the choices and make your choice. I will come to you individually to listen to what your choice is.
Teacher, should you answer in chat?
No, let's do this. Let's do this verbally. Let's do this verbally. Okay. Najib Iyad. Najib, salam alaikum. Can you unmute yourself, please? Najib
عليكم
Iyad.
السلام مستر.
Najib, what's your answer here?
B.
B. Why did you choose B, Najib? Can you explain?
Lecture I didn't understand.
Okay, so it's just a guess then, yeah? Okay, Najib chose B, which says it's a gray metal is seen at the anode. Now, at the anode, we know that there is bromine gas, because bromine is produced at the anode. And those, we go back, bromine molecules are produced at the anode there. You can see surrounding the anode, you've got bromine molecules being formed. These are bubbles, says it there, bubbles of gas on electrode surface. So this gas is bromine gas, because we know that bromine, from our half equation, we know that the product at the anode is bromine. So this gas is bromine gas. The bromine gas will rise to the surface and escape the electrolyte into the atmosphere as bromine vapor there. Now, bromine, if you remember what we, in chapter 1, okay, particulate nature of matter, when we looked at Brownian motion, okay, and we say that red-brown bromine diffuses from an area of high concentration to low concentration, okay, when we were looking at diffusion in the laboratory. And we looked at bromine as an example for diffusion in gases. Yep. So bromine, it's a red-brown gas that therefore our bromine that is escaping our electrolyte there, these bromine bubbles that will rise to the surface and escape our electrolyte, they are, this is bromine gas and the color is red-brown, pretty much like the color that you can see there. So that should make it a lot easier for anyone to answer this question. So I'll come back to, let's see, Muniz.
Yes,
Yes, what's your answer?
I chose C.
You chose C. Okay. Anyone else has chosen C? You can speak freely, everyone.
Yeah, I chose C.
Have,
Teacher,
I think C.
anyone think it's anything different from C? How about D?
if B said a gray metal is seen at the cathode, would it be correct?
Yeah, a red brown metal is seen at the cathode. Well, if
If it
anyone
said
knows
gray,
what
it'd be
lead looks
correct.
like, lead is not red brown, is it?
Yeah. So if it said gray, that would be correct.
Exactly. So the correct answer there is indeed C, guys. Your correct answer is C. Yes, correct answer there is indeed C. Now let's move on. Any questions regarding this exercise? Any questions regarding this exercise? Yes, I've got two hands raised. Malik,
I forgot it there.
okay, who else? Man Al-Hadi. Yes, man.
Teacher, so do we need to memorize or remember the colors of gases
Yes, it
and
will help.
metals?
It will help you to remember the color of your gases like bromine and chlorine and so forth.
Thank you.
However, for this particular question, even if you didn't know what the color of bromine was, the fact that it is a gas there, and from the electrolysis process, you know that the only gas produced in the electrolysis process was at the anode. Okay, so that's a big clue that what they're talking about there is the bromine gas. Also, you know that the product of the anode is bromine from your half equation. Okay, so there are lots of other clues that would indicate that your correct answer there is C. Okay, how are we doing for time? So we've got another 10 minutes. Let's move on to the electrolysis of concentrated hydrochloric acid. So first of all, I've got to make a correction here. It says dilute hydrochloric acid. This should actually be concentrated hydrochloric acid. So when you open this on Schoology, please correct it. Please correct it. Okay, it is concentrated hydrochloric acid. Now it's the same procedure. Okay, I can go ahead and explain the whole thing again, but there's no need to. What I will do, I will write your half equations at each electrode so you can see what is going on at each electrode. But the procedure is the same. The anion there moves to your anode, that is your chlorine. It gives up its electron, okay? And that electron travels through the circuit and is accepted by the cation, which is hydrogen. In both cases, a gas is formed. Chlorine gas is formed at the anode. That is the gas that is bubbling off at the anode there. And hydrogen gas is formed at the cathode. That's the gas bubbling off there at your cathode. Now, one key thing to make note of, this is a concentrated solution of hydrochloric acid. Therefore, the ions present there would be hydrogen ions from your acid, okay, H plus ions, and Cl minus ions from your acid. Okay, so I'll say there HCl produces those ions. but also because it's a concentrated solution. It's a concentrated solution. Your acid there is a concentrated solution of your acid, which means that it contains water. Whenever you see an acid, concentrated or diluted solution of an acid, water is present. So what are the ions that are present there from water? H2O produces H plus ions as well, and OH minus ions. Now I know some intelligent student is going to say, but water is a covalent compound. Yes, it is. It's a covalent compound. It's bonded covalently. But water partially ionizes. Partially, a small percentage of water forms H plus and OH minus ions. Okay, and therefore we must consider these ions when we're looking at electrolysis process. So the ions that would be attracted to the anode will be chlorine and the hydroxide ion. These would be attracted to the anode. And to the cathode, well, it's only one ion. It's H plus ion would be attracted to your cathode. Is everyone with me so far? Can I get an answer? Is everyone with me?
Yes, yes.
Yes.
Yes, yes.
Yes.
Excellent.
Yes.
So you've got 3 ions present in this electrolyte. You got chloride ion, 2 negatively charged ions, or 2 anions, as we call the negatively charged ions, we call them anions. So you've got 2 anions, chloride ion and the hydroxide ion. Now, which of them will be the product at the anode? They're both attracted to the anode, but only one of them will be the product at the anode. Now, the rule is here that if it is a concentrated solution, if it's a concentrated solution and it contains chlorine, okay, if it's a concentrated solution and it contains the halogen chlorine, the halide chlorine, then chlorine will preferentially be the product at the anode if the solution is concentrated. For any other solution, the product at the anode will be oxygen. The hydroxide ion there will move to the anode and it will release oxygen. Okay, so only for concentrated solutions of chlorine, the halide there, you would get chlorine forming at the anode. And this is exactly what happened there. Now let's look at the half equation at the anode. So what you've got there is 2Cl minus, 2 atoms of 2 ions of chlorine, 2 chloride ions will move to the anode. They will each give up 1 electron. In total, they would be giving up 2 electrons, so minus 2 electrons to produce a chlorine molecule. And that is the chlorine molecule, the greenish, it's a blue-green gas that would be produced around your anode. You'll see the bubbles of this chlorine gas on the surface of your anode, and it will escape the electrolyte as chlorine gas in the air. So suddenly you'll get this smell of a swimming pool. Yes, because of the chlorine, it smells like you're around a swimming pool when you're actually performing this experiment. Now, this is the experiment I sent you that I conducted in the lab with your colleagues last year. So the bubbles that you're seeing on the, when you're looking at your screen, the bubbles that you're seeing on the right hand side, that's the bubbles of chlorine escaping. Yes, and the one on the left hand side are the bubbles of hydrogen. Someone said he didn't understand the experiment I sent you. So now you should be able to understand that. Okay. Now the half equation at your cathode will be H plus, again, 2H plus will accept, each of them will accept 1 electron, so in total 2 electrons, okay, to produce a H2 molecule, which will bubble off there at your cathode. Again, at your cathode, it's always reduction, and at your anode, it's always oxidation. Any questions regarding this?
But Mr. Yes, Mr. On the right there are 4 chlorine atoms.
No,
Not atoms.
this is just an
Yes.
the amount of ions that are present there is we've got millions of ions present in this electrolyte. This is
So we only take 2.
yeah, we only wrote these for to explain. Okay, it could have been 5, it could have been 2 only. The point is each chloride ion will move to the surface and give up 1 electron. Then to form chlorine atom. Then the 2 atoms will react to form a molecule. And that's how we write the half equation. Okay, any other questions before I move to your final assessment? I don't know how much time do we have left. We've got 2 minutes left.
Teacher.
Yes.
Can you go back to the page?
There's not an assessment coming up. Coming up is the half equations, which we just completed. Yes, someone was about to say something. Go ahead, please.
Me. Teacher, in right here, you see the chlorine gas. It comes. It just it bubbles out, right?
Yes.
Now, does it bubble out after it attaches to the what's it called, the anode? It bubbles
Yes,
up.
of course, it is formed on at the surface of the anode. Here, this is where it is formed, and then it of course is a gas, so it is less dense than the liquid electrolyte, so it will move to the surface. Okay, because it's a gas, and then it will escape as chlorine gas. Okay.
And one last question.
Yes.
How does the full ionic compound divide in the first place?
The full ionic. Yes. Now, what happens? The water molecules gets between the hydrochloric, the HCl there. Okay, so this is what you've got, H plus and Cl minus. When you dissolve hydrogen chloride gas, okay, in water, when you bubble it through water, what the water does, it gets between the hydrogen chloride and split them apart into their individual ions. So you'll have H plus and Cl minus ions.
It seems very simple. Just put water and then it divides.
Yeah, it's quite simple. Initially, hydrogen chloride is just a gas. Yes, it's an acidic gas. It's just a gas. It becomes acidified when when it's dissolved in water. Okay. Now we don't have enough time to talk about the reaction at each electrode, but you've done this. You've looked at it, or I should say, it has been discussed while explaining the electrolysis process. So I'll say to you boys, go to Schoology, open this slide, and just read through what's happening here. Okay, here for what happens at the cathode, the reaction at the cathode, I've looked at both, not at the cathode, I've looked here at the reaction of dilute hydrochloric acid and concentrated hydrochloric acid, just to give you an understanding as to what happens if the solution is diluted. Okay, note that if the solution is concentrated, like I said, the product at the anode is chlorine. Okay, if the solution is diluted, okay, then the product is different. It is oxygen. Hydroxide ion moves to the anode, but oxygen is produced as your product at your anode. Okay, so very important for you to ascertain, to determine whether your solution, whether your electrolyte is a concentrated solution of a halide, of which chlorine is one of them, or it's a diluted solution, because that would determine your product at the anode. Okay.
Okay.
And this is and of course, here you've got the products at your electrode for the electrolysis of lead bromide, the very first one that we did. Okay, so in a way, we've completed this slide as well. So the next time we meet, we'll be looking at the rules for electrolysis of aqueous solutions of ionic compound. Okay, so that's our next objective. Inshallah, when do I have you again? Tomorrow, isn't it? Yes, your final session of the week. So that's all we've got time for today, guys. Thank you very much. And I'll see you tomorrow. Assalamu alaikum wa rahmatullahi
Walaikum
wa
salam.
barakatuh.
Walaikum